Okay, hi. This is Jake Simpson. Just recording my video for Lab 5 here, explaining the HDMI to HDMI pass-through on the Zybo Z7 SoC. So in the general data flow, we have our constraints here connected up to this DVI to RGB block. So this takes the TMDS input on our actual physical constraints and then converts that to 24-bit parallel RRGGBB data, um, kind of like the reverse of what we were doing in last lab. We're taking it in and then converting it into that data. Then we take that and we put it into an AXI stream format, which then can be used elsewhere in our video pipeline, right? So that is what the VDMA expects and what other peripherals expect and our AXI interconnects. So we use this block to convert that video into an AXI stream, and then we use the AXI stream subset converter to convert the 24-bit RRGGBB data into 32-bit data that can then be interpreted by the VDMA. So we're trying to write this frame data into the DDR. So we need the VDMA to write that frame data into the DDR, and it expects 32-bit data. So we're converting 24-bit into 32-bit. Then when we want to read the data, we obviously need to reconvert it into 24-bit data from the 32-bit memory DDR format that we stored it in using the VDMA. So we have another subset converter bringing that back to 24-bit data, and then kind of the exact same but opposite AXI stream to video instead of video to AXI stream to pack that into parallel data for our RGB to DVI output. And then just like last lab, this RGB to DVI output drives our HDMI transmit. So you can see these are connected to the HDMI out constraints from my XDC file. So there's a few things I didn't specifically mention just because I don't want the video to get too long, because on my Linux computer these screen recordings keep corrupting for some reason. But other blocks that are notable that I talked about in the report are just kind of like the clocking, the video timing. This creates the H-sync, the vertical and horizontal synchronizing signals to actually draw the data on the screen. And then there's different kind of there's a block here for crossing clock domains, and then various constant blocks to configure other IPs. But yeah, in general, I think that should explain it pretty well. Now, after doing this, we obviously exported the hardware, generated the bitstream so we could grab the Xilinx support archive file, and then from that, I moved over to Xilinx Vitis, and I created a platform. You can see I have two for Lab 5. That's because I created an initial platform with the 720p pass-through, and then I created another one with 1080p. I changed the RGB to DVI and DVI to RGB blocks to support the 1080p. Then to update that on my system, I just modified the SPRGA file and changed the platform that it's pointing to, and then right-clicked, I clicked run. I'll just upload it on the board really quickly during this video so we can look at the PuTTY terminal. So really quick, I'm just gonna bring up a serial monitor at 115 200 baud rate, and then I'll flash the board. Let me just get rid of this previous system configuration. And let's see, so once we right click and click run on hardware, we should see the HDMI menu kind of loading, because there's a menu where you can choose specific outputs, right? So here you can say one to change, you can display the test pattern generator. There's a bunch of built-in functions in this script that we were provided for the lab. But yeah, I've tested this, and I'll include the videos of the 1080p HDMI pass-through working. Thank you.